Swayam Prabha. Digital India. Educated India.
So, T was defined as beta 1 hat plus beta 2 hat divided by variance of beta 1 hat plus variance of beta 2 hat plus 2 into covariance of beta 1 hat, beta 2 hat. Okay, beta 2 hat. So, this we have discussed yesterday, but testing this linear restrictions, this particular test you can also conduct. That means, the test statistic can be alternatively formulated as using F statistic also, that we have not discussed yesterday. So, let me talk about the application of F statistic to test the same hypothesis of testing linear restriction. Okay? Testing linear restriction. So, that means, I will write our production function once again, yi basically log of yi equals to log of beta 0 plus log of plus beta 1 log of x1 I plus beta 2 log of x2 I plus ui. This is what the production function after taking log. Okay. Now, in this particular production function, we will impose the restriction, and what is our restriction? Beta 1 plus beta 2 equals to 1. Okay. Beta 1 plus beta 2 equals to 1. So, that means, from there what I can write as beta 2 equals to 1 minus beta 1, or beta 1 equals to 1 minus beta 2. Okay, 1 minus beta 2. So, you can either substitute the value of beta 1 in terms of 1 minus beta 2 or beta 2 in terms of 1 minus beta 1, okay, in terms of beta 1. So, let me then put the value in this way. So, I will substitute beta 2, this would become log of beta 0, okay, plus beta 1 log of x1 I plus, in place of beta 2 I am putting 1 minus beta 1 log of x2 I plus ui. Okay. All right. So, that would become log of beta 0 plus, here you have beta 1 log of x1 I. So, here you have minus of beta 1 log of x1 I. So, that means, you can take beta 1 common, and this would become log of x1 I minus log of x2 I minus log of x2 I plus log of x2 I plus ui. Okay. Now, this log of x2 I you can take left hand side. So, that will make log of yi minus log of x2i log of x2i equals to log of beta 0 plus beta 1 log of x1i divided by x2i divided by x2i plus ui. Okay, and this would become log of yi by x2i equals to, I can take this as a constant log of beta 0, let us say this is some constant a plus beta 1 log of x1i divided by x2i plus ui. Okay. Is this fine? Okay. So, that means this particular, from this particular equation what I can say that output per unit of capital is actually a function of labor per unit of capital, okay, labor per unit of capital. And this particular equation is called the restricted equation, restricted model. Why this is restricted model? Because this model I have derived after imposing the restriction beta 1 plus beta 2 equals to 1, okay, beta 1 plus beta 2 equals to 1. And our unrestricted model is basically this one. This is our unrestricted model. Okay. So, I have not done anything new, I have simply imposed the linear restriction beta 1 plus beta 2 in the model, then ultimately I have come up with this model which is the restricted version of this equation, which basically says this is the output capital ratio which is a function of labor by capital. Okay. Similarly, if you put the other restriction, see here I have imposed I have substituted the value of beta 2 with beta 1. Similarly, you can replace value of beta 1 with 1 minus beta 2, and in that case you will get another version of restricted equation which would become log of yi divided by x1i would become a plus beta 2 log of x2i divided by x1i plus ui. Here this is another version of restricted model, this is also restricted model. Instead of saying equation, I will say this is restricted model 1, this is restricted model 2. So, both are restricted versions. Now, for economists, the restricted model 2 is more appealing and more used in the literature, where we assume that output labor ratio is a function of labor capital ratio, okay, capital labor ratio. Okay. How much capital per unit of labor is endowed with? So, 1 unit of labor, how much capital that particular labor is getting, that will determine the labor productivity, because this left hand side output by labor which is called labor productivity, average productivity of the labor. Average productivity of the labor is determined by how much capital is allocated per unit of labor. So, equation 2, you can get both the versions, not a problem from econometric point of view. Either you can substitute beta 2 for beta 1 or beta 1 for beta 2. What I am saying that the restricted version, restricted model 2 is more appealing for the economist and more used in the literature compared to restricted version 1. Okay, restricted version 1. Now, what we will do, from these two we will construct another test statistic to test the validity of this linear restriction. Okay. So, what we are testing? We are actually testing the validity of this linear restriction beta 1 plus beta 2 equals to 1. And if you look at the way we are deriving, we are substituting, that means initially we have assumed the restriction is valid. If the restriction is valid, then I can substitute beta 1 for beta 2 or beta 2 for beta 1, then I can test, I can get two restricted versions of the model, one is restricted model 1, another is restricted model 2, then look at how I am constructing the test statistic. Okay. The test statistic is RSS. This test statistic is defined in terms of RSS, not R square, RSS restricted minus RSS unrestricted divided by M. And what is M? Please keep in mind, M is number of linear restriction. So, I will write here M equals to number of linear restriction, which is 1 in this particular context, divided by 1 minus RSS R, which is equals to N minus K, where K is number of parameters to be estimated in the restricted model. K equals to number of parameters to be estimated in the restricted model. Okay. Now, first question, if you look at the earlier F, that means when we are testing the equality between two regression coefficients, we are using F statistic, but that F was defined in terms of R square new and R square old. Then why we are not using R square to define the same test statistic here? See, we are not defining R square in this model because if you look at what is our two models, if you compare the restricted and unrestricted model, see, an unrestricted model, what is your dependent variable? Your dependent variable is log of yi. But in the restricted model, what is your dependent variable? Log of yi by x1i. So, that means the dependent variable of the two models are not same. And when the dependent variable of the two models are not same, please keep in mind that R square is not comparable. Because what is R square? R square basically the proportion of the total variation in the dependent variable that is explained by your explanatory variables. Since the dependent variable itself is different in two different model, then I cannot say that these two R square are same. That is the reason the R square what we get from the unrestricted model is different from R square what we are getting from the restricted model. That is the reason these two R square are not comparable. So, alternatively we are defining our test statistic F in terms of RSS. RSS R, that means RSS from the restricted model, RSS from the unrestricted model, 1 minus RSS restricted, and K equals to number of parameters to be estimated in the restricted model including intercept. That also you should write, including intercept. Including intercept. Okay. All right. Now, here if you forget whether the numerator should be RSS R minus RSS UR or RSS UR minus RSS R, you just think out of these two RSS which is more. Obviously, when you put restriction in the model, you have less number of explanatory variable. That is the reason RSS would be higher. Quite simple, quite understandable. In a restricted version, you have less number of explanatory variable. That is why when the number of explanatory variable is less, obviously the residual part would be more. So, that is why RSS R is always greater than or at least equals to RSS UR. It should not be less than RSS UR. That is the reason, if you remember that point in mind, then you will never get confused between whether the numerator should be RSS R minus RSS UR or RSS UR minus RSS R. Okay. So, you can estimate the two models and then you can collect RSS R, RSS UR, and then you can put this value and you can always get the value of F statistic. Okay. So, now what I will do, I will go back to again the data set. Okay. So, I will now show you how to estimate this model. So, for that I am just exiting from this child mortality data. I am opening a new data set. Okay, I am opening a new data set which is given here in this capital lever. So, this is our data, this is a time series data. This is a time series data on real gross product. And then I am again putting this into stata. Hello.
Hello, Dr. Sabut Kumar Mandal.
Yes.
Sir, my name is Syed, calling from LNT, that Praganya Eden Park, you know, sir, in Siriseri.
Please call me after 1 hour. I am in a meeting right now.
Sure, sir, I will make a call, sir.
So, I will put that into data editor here. Okay. So, this is how just a second, I will just try to see what is happening here. So now if you cancel this, okay. So here I will now, what you have to do, you have to estimate the model, right. Now see our variable, if you look at our variable is in nominal term, that means we have variables are in level, you have output in level form, you have capital and labor both your level form. And how we have defined the variable? So we have defined the variable as this, we have defined as, see, look at real gross output, then labor days, gross output, then this is real gross product, real this, then labor days and real capital, okay, real capital, just 10 minutes more, okay. So first thing what we have to do, if we want to estimate this model, we have to convert all these variables into log form, right. And how to do that? I will just show you how to convert the variable in level form in log form using stata command, okay. So that is also something to learn, so I will now show you that, all right. So here the command would be, please keep in mind, command would be gen. I am giving a name for the variable that I am going to generate, let us say gen L, and then I am putting output, okay, all right. So this is become this, how I am defining the variable, log of in the model, then you have to go back and see how you have defined the variable, sorry. This you have to see how you have defined the variable. So there you have to just go to data editor and just you see this is real gross output. This is how I have defined real gross output. So when you are converting this variable into log form, you have to just put this variable name after that log function, then it will work. So I will show you how to convert one variable. So log of real, then gross output, then bracket close, and if you put enter, so that means I have made some mistake there in defining the variable. Let me see once again how I have defined the variable. So, I have said real gross output, how it is defined there? Oh sorry, real gross product. See, you have to exactly type this variable name. If you commit mistake there, then it will not come. Real gross product. So, instead of output, what I will say, this is gen L0 equals to ln real gross product, real gross product. Okay. Then if you put enter, it will work. Okay. So, that means now I have converted the level variable of output into log form, and the variable is defined as L0. Similarly, I can look at what is the variable name for other one, which is labor days and real capital. See here L0 is there. So, that means the variable is converted into log. So, this is labor days and real capital. So, same way you have to convert these two variables also, labor days and real capital. So, I will put another gen command, gen, let us say that is L1 equals to ln labor days, and this variable is now converted into log. And then the third one, gen L2 defined as ln in the bracket real capital. So, all the three variables are now converted into log. Okay. So, my dependent variable, which was real gross product, that is also now converted into log form and defined as L1, L0. Then labor days, labor is measured by labor days, which is also now converted into log and defined as L1, and capital variable is also now converted into log of capital, and that is defined as L2. So, now all your variables are converted into log, and you can easily run the regression, which is reg L0. So, L0, then this is this is not L0, this is LO I have given, equals to then L1 and then L2. This is how I have now converted the linear model into a log linear one, and you can put enter. Okay. So, this is your unrestricted model. And from here what you have to do, you have to collect your RSS. Look at what is your RSS, residual sum of square, which is 0.0671. So, this you have to collect, which is RSS, this is RSS UR, because I have not yet put any restriction in the model, that is why it is called RSS unrestricted 0.0, what is the value? 0.0671. This would become your RSS UR. Then you have to estimate the RSS restricted one, and how will you do that? Again you have to convert your dependent variable into labor output ratio, independent variable as capital output ratio, and how will you do that? Simple, again using the gen command. So, if you use gen command, then you have to simply put one name, let us say gen L output, that would be defined as, how it will be defined? defined as output by labor. Similarly, you can put a name for labor capital ratio, capital labor ratio, and then that would be defined as capital divided by labor. And once you do that, you can estimate the model of unrestricted one and then restricted one, and then you have to collect the RSS from that restricted version. So, we will discuss about the remaining portion of this estimation in tomorrow's class. We will estimate the restricted model in tomorrow's class. Thank you.